All right. So let's talk about day 28. So there's this question called rotating oranges. Oranges. This is the question which I solved on lead code. And I guess day 28 was pretty hectic. I also gave an interview and I didn't get much time to, work on anything. So yeah, that was all about day 28. And about this rotating oranges. Sorry, not rotating, it's rotting oranges like this. Suppose there is an orange which is rotten already, and then there are some couple of good oranges. Then what happens is these oranges keep on getting rotten. So at 1 minute, these two will be rotten. At another, at 1 minute and second minute, it will be like this one will be rotten either from this one or this one. And second, after third minute, it will be rotten, and this one will be rotten, and this one is still remain fresh because we can't just reach here by any means. All right. So what do you think the one solution will be? So let me give you an not trick or something, but those who are not that much familiar with when to apply BFS, when to apply DFS, let me tell you one thing. Suppose if you are here and you want to go like uniformly go in all direction at one step and then want to go to another step, all right, then you will apply BFS because first you are covering all these adjacent ones and then you are moving ahead, all right. So in these cases you will apply BFS. But suppose if you are here and you want to go through like this one all the way to the end, or maybe somewhere here, but you don't want to go like, okay, I'll go from here as well, right? So then probably you will end up using BFS because so see what the thing is that I have noticed this. I don't know if it is true. BFS you apply when you want to see like minimum time, minimum traversal, minimum amount of something to reach somewhere at some point in the graph. And but DFS is like how much, how much, all right? Because you are just gonna keep on continuing traversing at until the end. So basically, if you want to go from here to here in a grid, how would you go? I mean, this could probably a way, no? And there could be another way. So in these cases, you might, if you know that this is the location, you can use DFS and keep a count of the size. Like, okay, this one when you reach, you had like suppose you are maintaining a minimum um, number of traversals needed, and once you reach here, but I mean, suppose you reach there by this path, you would simply check, okay, mini is uh, if it is greater than this count, then we'll simply say mini equals to count. All right. So at the end of the time, at the end of the loop, you will get your minimum number of steps to reach there, something like that. Okay. So this is something. All right. So day 28 is covered, and day 28 was yesterday. Okay. Let's move on to day 29 then. Thank you.